please give me a thumbs up. Babalo, please close your camera. Thank you. Okay. Please, good people, make sure that you do not open your camera. So I said, as soon as you can see that it's recording on your side, please give me a thumbs up. Okay. No problem. So rules of the house. Well, this is not really a house. There's an online house. So unless you are asking a question, please make sure that you are muted. You can only unmute when you're asking a question. Okay. This will help you when you watch the recording later, because you will not be feeling any or hearing any noise which you shouldn't be hearing. So to avoid disturbances, please make sure that you are muted unless you want to ask a question. And then rule number 2, there is no stupid question, okay? If I am doing something on my screen and you happen not to understand, at any point you can unmute as I'm doing whatever which I'm doing and ask your question and say, I do not understand how you moved from here to here. Okay, we are here because you should understand the work. So when you do not understand, just unmute and make me to stop. I will be very happy to go back and clarify whatever which is confusing you. And then another thing, there are people who cannot use their mic. So some people are in libraries, some people are somewhere where they cannot use their mic. Those people can use the chat section. So if you look at your screen carefully and just move your eyes around, you should be able to find where you can type a message. And the people who can use their mic, please make sure that when you see a pop-up message, you read it on behalf of your classmates. My response might be useful to you too. Okay, those are our house rules. And now let me open up for questions. So before I deliver my speech, do we have anyone who has a question, be it about the session, be it about maths, or in general, be it about second year? Please go ahead. No need to be uptight. Do you have a question? If you do, please go ahead. Any question? It can be about the course itself, or it can be in general. Okay. Since there's no question, please go ahead. Any time to ask me a question.
No, sir.
Okay, no problem. Please mute yourself. Okay. So we'll always be muted unless we are asking a question. Right. So let's quickly have a chat about this course here. So everyone in the meeting is doing maths 2011. 2011 would be the people who are doing chemical, and 2011 would be the people who are doing mechanical, chemical, and aeronautical engineering. So let's quickly have a chat about that. And me split my screen here. So in the meeting, we have people who are doing maths 2011. And those would be the people who are doing Chem Eng, and also people who are doing Mech are doing exactly that. And then we have people who are doing Aero. Well, this feels very wrong. But anyway, you get the point. And then we have people who are doing math, the session 2014. And those people are the people who are doing either EE, or they are doing IE, or they are doing BME, which is biomedical engineering, or they're doing DA, which is digital arts. And then lastly, in the meeting, we also have people who are doing Maths 2026. Okay. And those people would be the people who are doing mining and the people who are doing civil and also the people who are doing metallurgy. So I'll call that MET. Okay. So all of you for first semester, you'll be doing exactly the same work. The only difference is that these ones, they are doing this course for the whole year. It is a year course for them. And these people who are doing Chem-Eng, Mech and Aero, they are doing Algebra plus Cal. And then the people who are doing Maths 2014, these would be the ones who are under the School of EIE. They are also doing this as a year course. And they are doing Algebra plus Calculus. And then they have an extra component, which they call TSF plus TSF. That's the difference. But otherwise, besides the TSF component, they will be doing the same course as the Maths 2011 people. And then 2016, which is the mining people, civil and metallurgy. This one is a semester course, meaning you only do it for the first semester and you are done with this course. It is only the other two guys who are going to carry on. And obviously you'll be doing algebra plus calculus only. Okay. So we have all engineers first semester, they are doing the same amount of work or the same work. The only difference is that the electrical people or the EIE people who are doing Maths 2014 have an extra component which is called TSF. Okay. And then over the years, how are people finding the course? Obviously, difficulty is relative. Okay. What is difficult to person X may not be difficult to person Y. But what I can say to you is that these courses are not hard. Maths in general is not hard at all. It just depends on how you go about doing the maths. And one thing I need to bring to our attention is that the way we see maths should change from today. We shouldn't see maths as this course which is going to bring problems in our lives. We should see it as a course which is going to bring solutions to our lives, because this maths which you are doing this year does not stop here. For example, the people who are doing Maths 2011, let me take mechanical and aero, they will do Maths again a third year. So they have Maths 3. It means if we develop an attitude which is not good towards Maths, you still have Maths 3, so I'm not sure how that is going to help you. The same way with the people who are doing Maths 2014, those would be the EIE people. They do Maths also a third year, besides the biomedical and the digital arts guys. So the ones who are doing electrical and information, a third year, they will also do Maths. So it means the attitude which we have towards Maths needs to change. It is not a good one, because you are stuck with Maths and do not see Maths as a problem. It is a course which is going to help you as an engineer to solve the problems which you will face in the future. And then Maths 2026, that would be the civil, mining and metallurgy people. Let's start with mining. Just because you are doing mining, it doesn't mean that you should have an attitude towards Maths. In fact, people who are doing mining will use the same course in third year, Maths 2026. There's a course they call rock mechanics at third year level, and the prerequisite is Maths 2026. So if you understand this course, automatically there's a third-year course which you will kill. And if you do not do well on this maths and it goes below 50, it means there's courses which you will not take. So this idea that mining, we do not need maths, you should take it out because you have third-year courses which are mathematically intense. Okay. Same applies to civil. I mean, if you are doing civil engineering and you can't solve equations, you can't solve differential equations, you can't solve simultaneous equations, you will be faced with structures and all the other courses. You will need your Maths 2026. Same goes with metallurgy. So everyone who's in the meeting here, this course here is not stopping this year. So next year, one way or another, it will follow up and build up on another course. So what I'm asking you to do is to please have a good attitude towards the course. And obviously, to have a good attitude towards the course, you need to pass it. Because if you're not passing something, then where is the good attitude going to come from? And if you look at previous statistics, let's quickly jump into that, because someone else is like, are people really failing this course, or are people passing this course? Well, I said difficulty is relative, but many people have not been doing well on the course. And then those few who are doing well are doing exceptionally well. So you need to make sure that you find yourself among those who are doing exceptionally well on the course. If you look at last year's June exam for the results, in fact, if you look at the test they wrote before the June exam, I forgot the pass percentage, but I can drop it on the group. It was not looking good at all. And same goes for the final exam. So many people did not make it. And was the exam hard? I believe not. It was doable. It is just that people, to some extent, did not understand the basics. What I mean by the basics is that if we do maths, we cannot work on memory. Okay. You can have all the big memory, but if you use it, it will work against you. So we'd rather understand exactly what is going on. And then when they tweak a problem, you know exactly what to do. But if you try to memorize a problem, that's where people start facing problems. Have you ever been in a position where you go in an exam room and you come out and you think, I did well, and when the results come, they say otherwise? It does happen. And the reason is because many people work with memory. So because I've seen such a problem, when you see the problem in the exam, you do not look at the differences, you just go straight to what you've done before, and then you take a shot. So my advice to you is please, whatever you do, make sure you understand. Memorizing is not big in engineering. It doesn't help us a lot. Memory is good, but it doesn't help you a lot. Rather understand, why are we doing this? You understand why we are doing it. If I give you a problem, you'll be able to think around the problem. And the intention, the sessions which we plan to host on a weekly basis, is to equip you with exactly that. You should be able to think around the problem, not memorize around the problem. Okay. Do we have anyone who has a question? Please go ahead. Anyone has a question, please ask before we get to the contents of the session. The maths is easy. It is just our mindset, which we need to shift and fix, and then we will pass this course and many other courses. And here's an advice also before we kickstart. Please make sure that you work in advance. Okay. If you look at university and how it is structured, back in matric and first year, let me say in matric, science was complex. You all did science, and apparently it was the most difficult thing at that level. and you're all able to pass to get here. So meaning your brain does not struggle wrapping around complexity. Your brain does not struggle understanding complexity. The only problem we face when we get to Wits is that we have complex concepts, and then we do not have time on top of that. That is the biggest issue. So imagine you are faced with complexity, and then time is also not on your side. So you now have two things which are fighting against you, which is why many students find themselves not doing well. And can you make more time? Unfortunately, you can't, but you can make more time by working in advance. This past week was your week one. Do you understand all your week one work, or you want to leave it until week 4, which would be around early March when you are going to your test? And then that's when you will realize that you didn't understand what a linear operator is. You didn't understand complex numbers. So my advice is please work in advance. That's the only way you can buy time. Work in advance, work in advance. The weekends should be productive. You cannot be going around if you do not understand what the operators are, or what linear operators are. How do I show that an operator is linear? Can you explain it to your sibling who's at secondary or primary school? If you cannot, then it means you do not understand what is going on. Okay, any questions? I can see there's people who are not muted. Kumalo, I think your name is Herbert. My apologies if I didn't spell that correctly, but please mute, and you can unmute when you are asking a question. Okay, look for the mute button on your screen and please click it. Then when you have a question, you can unmute and shoot. Anyone who has a question? Anyone? Hey. Someone in the meeting, please confirm if you can see my screen. You can just give me a yes. You can unmute. I can no longer see your screen, so I can't request thumbs ups anymore. You can just give me a yes if you can see my screen.
Yeah.
Okay, no problem, thanks. So dive into what is going on. Okay, so my question is, for your week 1, did you do linear operators or calculus?
Yes.
Yes.
Okay, no problem. And then for algebra, what did you do for week 1?
Complex numbers.
Okay, no problem. So it looks like you are up to speed. And then for calculus, did you eventually get to the operators?
We haven't started with D operators yet, if I'm not mistaken.
Okay, no problem. So let's quickly get up to speed with algebra. Okay, very easy. So chapter 1 of algebra is the easiest, and I see no reason why we should struggle with that. Okay, so let's quickly start with algebra. And if you didn't understand the lecturer, let's see if you can understand what you are supposed to take away from chapter 1. So I'll just say chapter 1 here so that I'm able to differentiate my pages, sort them out later. So if you look at your chapter 1 of algebra, your focus is essentially chapter 5 of algebra Med 1043. So essentially, our focus there is on complex numbers. And mute. It's very important that you always check your mic and see if you're not the one who is unmuted. If you can hear me, just quickly look at your screen and see, is your mic, does it have a diagonal line crossing it? Right, thanks. So let's quickly look at algebra and have a look at what they're expecting you to understand, which is complex number. And those who were attending last year, you should remember this is one of the easiest chapters. Okay. So they take you back to the basics of complex numbers. So when we are looking at complex numbers, what gives motivation for complex numbers, essentially, it starts from the square root of -1, which becomes I. So if you remember previously, story time, we didn't know how to deal with the square root of a negative number. If you go to your high school teacher and say to them, what is the square root of -36? They will say it is undefined. That's what they will say. And essentially, our algebra now is saying we are at a level where we can't say this. It's embarrassing. What we can say is that the square root of 36, -36, is simply square root of -1 times the square root of 36. But we know that the square root of -1 is I, the square root of 36 is 6. So our answer just becomes 6I. Okay, nothing out of this world. That's where we come from. And why do we even need to okay, as you are asking a question, good people, please keep it muted. So I was saying, we can no longer say what we were saying back in high school, that the square root of a negative number is undefined. So if you go to your friend tomorrow, you're meeting them and you are saying to your friend, what is the square root of -36? And they're saying, hey, we can't take the square root of negative number, cut them. Okay, cut that friend, especially if they're doing engineering, we need to ban them from the friendship. They can't say the square root of -36 is undefined. Right. But then there is another story. Let's quickly jump into the different types of, or the representation of complex numbers. So we have what we call the real form. If we look at a complex number, it is usually in the form of x of z, with form, sorry. So your complex number is usually given in the form of z is x plus I, y. So real imaginary form, missing that. Real imaginary. So we have what we call the real imaginary form of a complex number. And it looks as the one which we wrote below here, where the x is what we call the real part. Okay, that is for that. And then what multiplies the I is what we call the imaginary part. So whatever which always multiplies I is what we call the imaginary part. That's the imaginary part of the complex number, which is z. So that's why when a complex number is written in this form, x plus I times something, we call it the real imaginary form, because we have the real part. We can clearly see it, which is in yellow, I hope, or gold. And then we have the imaginary part, which is circled in green. And the imaginary part is whatever which is multiplying the I. Okay, very important to understand that, because when you approach the test, or when you do your tutorial questions, they will say express it in real imaginary form. You need to know exactly what they are looking for. Okay, let's quickly look at one example. Let me make them to be 2. So let's come here. It feels very easy, of which it should, but it helps to understand these things. So let's call it example 1, okay? If they give me that z is 1 plus I, all what I can see here is that this is already in real imaginary form. So I can see the real part, which is what is not multiplied by I, the real part. And then the imaginary part, I know it is whatever which the I is multiplying. So since I do not see anything, it means that I is multiplied by 1. So that becomes my imaginary part. Okay, nothing confusing. Let's take another example, and then we'll build on these ones slowly. The aim is to get us up to speed. So let's look at example 2. They say to us, look, we are giving you Z is 2 plus 3I. Okay. And then we want you to tell us what is RE of Z. So what this means here is that what is the real part of Z? And if you look at the real part, it is whatever which is not multiplied by I. So that means it is 2. And then if they come to us again and say, find the imaginary part, which they would write IM, the IM is for imaginary, and then they would put in the complex number inside, which is Z. All what they are saying is go to Z and look for the imaginary part of Z. That's what they are saying there. Go and look for the imaginary part of Z. And if you remember, with the imaginary part is whatever which is multiplied by I. So I is multiplying 3. So that means the imaginary part of Z is 3. Okay, this is nothing deep. And this is still the real imaginary form of a complex number. Right. Let me just go to example 3, and then I will pose the question to the people in the meeting, and then we quickly go down and build. So let's call this example 3. Okay. And then they say to us as a starter, because we want to get to understand this thing. The question is, find the, or they say, what is, let's say they say, what is the real part, or the real and imaginary part of Z? This is the question. And then they give us our Z as Z is equal to 9 minus 6I. So the question to the people in the meeting is, what is the real part? Remember, the real part will always put RE. Because we're looking for the real part of Z, we'll put the Z in bracket. So what is the real part of the complex number here? Is Z. Anyone in the meeting? Should be very easy.
It's 9.
9, okay. Real part is 9 because 9 is not multiplied by I, okay. And then let's say they are saying, again, which is answering the question, what is the imaginary part of Z? Someone else in the meeting, it's your time to shine. What is the imaginary? What is the imaginary part of Z?
-6.
On point. The imaginary part is always what is multiplying the I. So it is -6. Okay, I'm happy that people are getting this thing. So essentially, just wrap up this one, is when we are looking at the real imaginary part of a complex number or representation, imaginary form, your complex number must always be Z is equal to X plus I times something. If it does not look this way, then it is not the real imaginary form of a complex number. And this real imaginary form, it is also called So I'll just put AKA. Hope we all know that AKA stands for also known as. So this here is AKA, also known as, they can either say real imaginary form or they can say standard form. So if they say write the complex number in standard form, they still mean exactly the same thing. Write it as Z is equal to X plus IY so that it becomes easy to see the real part and it becomes easy to also see the imaginary part. Okay, and then let's quickly jump into what they present you with. So real imaginary form, we are still there. Let's quickly jump into what they call complex conjugates. We'll go to multiplication, do not worry, and other things. So let's go to what they call complex conjugates. So if we are given a complex number, Z is X plus IY, this is what we call the real imaginary form or standard form. If we want to take the conjugate, what we will do is we'll put a bar on top the complex number, X plus IY, and this bar here, show those who are rapping alike, we're putting bars here. This bar here, rather, is what we call the conjugation sign. So conjugation, let's say operator. Okay, remember we are focusing on complex conjugate. And what does a conjugate do? When you conjugate, essentially, you are changing the sign of the imaginary part. So when conjugating, all what you are doing is you change the sign. It's all what you do of the imaginary part. So that should be easy because we already know what is the imaginary part in a complex number. So let's think about this. So if I have Z is equal to X plus IY, and I conjugate, which means putting that dash on top, what we are saying here is that when you conjugate, you change the sign of the imaginary part. That's all what you do. So which means Z conjugate or Z bar should be X plus I. The imaginary part was Y. So when I change the sign, I just make it to be negative Y, which means I will now have X minus I, Y. Okay. If it doesn't make sense, please hang in there. Let's quickly jump into an example because they really help. So let's call this example, I'd like to believe 4. So let us say in this example, they say to you, find the complex conjugate of Z, which is the complex number. And then they give us that Z is 2 plus 3I. And then in my head, I'm supposed to say, okay, look, what do we mean again when we say complex conjugate? Then I should be reminded that all what I need to do is to change sign of the imaginary part. So meaning if the imaginary part was negative, I make it to be positive. If it was positive, I make it to be negative. Okay, sounds very easy. And you are right, it is because it is easy. So Z conjugate, which is what that bar stands for, it would put 2. 2 is the real part of the complex number, so we're not doing anything. Plus, the imaginary part is 3. And when I conjugate, we said I should change the sign of the imaginary part, which means let's go there and put minus 3 and then put in the I, and then this becomes 2 minus 3I. This looks like something which your sibling would understand, even if they are doing grade 8. You just tell them that, look, we have the real part, which is what is not multiplied by I. We have what is multiplied by I. We call it the imaginary part. When you conjugate, you change the sign of the imaginary part. What is the imaginary part? It is what is multiplying I. Very easy. Let's take example 5, which should be the last one on conjugates. And then I want to show you some magic. We'll need someone in the meeting to help me with example 5. So example 5, we are finding the complex conjugate is always of Z. And what we are given is that Z is 16 minus 25I. So let's start here. Let's make it easy. I need someone in the meeting to give me what is RE of Z. RE, remember we said it is the real part. So someone in the meeting, please go ahead. Someone in the
16.
16. Okay, very easy. And then someone else in the meeting, please give me IM Z. That would be the imaginary part. Come on, good people.
Negative 25.
Negative 25. Thank you. Okay. There we go. That is easy. And then now let's look for Z bar. Someone in the meeting, please give me what Z bar is. We're putting on some bars on Z.
16 plus 25I.
16 plus 25I. Very easy. Okay. Right. So now we are done with complex conjugates. Let's quickly jump into the easy operations of multiplying these complex numbers and dividing them. You will see why we're doing complex conjugates shortly. Okay. So let's quickly start with some operations on the next page. And I need you to follow me. Let me just say operations. So let's start with the easiest one, which is addition. Okay. Let's start with addition of complex numbers. Very easy. So let's say we have a complex number Z. I'll call it Z.
Yeah.
Someone is not muted. Please check. There's people speaking behind you. Thanks. So let's say Z1 is X1 plus I, Y1. And then let's say we have another complex number, Z2, which is X2 plus I, Y2. So when we do Z1 plus Z2, the answer is easy. So all what you do is you add the reals together, add the reals and then plus I, and then we add the imaginaries. It is that easy. So let's quickly do our addition above. So our Z1 plus Z2 will be X1 plus I, Y1 plus X2 plus I, Y2. Then as we can see, these are the real parts. So we will add them together. And then those are the imaginary parts. We'll add them together. So our Z1 plus Z2 will simply be X1 plus X2 plus, I'll take out the I and then simply add the imaginary parts, which are just Y1 plus Y2. Okay. And then now a question, which I'm going to bring up from this is, what is the real part of Z1 plus Z2? Someone in the meeting, give it a shot. This is your time.
X1 plus
X1 plus X2.
X1 plus X2, very easy. Okay, and then someone else in the meeting, it is your time to shine. What is the imaginary part of Z1 plus Z2?
Y1 plus Y2.
Y1 plus Y2. Okay, that is what is multiplying the I. Very easy thing, right? So let's quickly do an example. See, I easily lose track of numbers, 6. So example number 6. So we want to find, or we are required to find Z1 plus Z2. But let me not call it Z. We are required to find Z plus W, where the Z is simply 3 plus 2I, and the W is simply 10 minus 15I. So now my question to people in the meeting, you should take out your pen and quickly guide me. What is Z plus W? Or rather, what is going to be the final answer? I'll just write the step after you give me the final answer. When we add Z and W, what do we get? What would be the real part?
13.
13.
And what would be the imaginary part?
Minus 13.
Okay, minus 13I. Okay, so all what we did, to someone who does not see it, is 3 plus 2I plus 10 minus 15I. So if you look carefully, this one is real. So both of them are real, they belong together. Okay. This one is imaginary, and this one is imaginary, they should be added together. So if you look carefully, that 3 plus 10 will give us the 13, and then 2 minus 15 will give us negative 13. Nothing hard at all. So let's quickly look at subtraction. Okay. If you happen to know these and you are ahead, please hang on. Then let's look at subtraction of complex numbers. Subtraction and addition are good as the same. Okay. So if we have Z is X1 plus, so let's just say Z1, and then I, Y1, and then Z2 is X2 plus I, Y2. If we do Z1 minus Z2, all what we do is you just subtract the real parts. So let's go, it is X plus IY. This is 1, 1, minus our Z2, which is X2 plus IY2. So if you quickly distribute the negative, you will see that we have X1 plus IY1 minus X2 minus IY2. Then now we group the reals. So this is real and this one is real. We need to group U. And this one is imaginary and that one, they are imaginary. We need to group them. So our answer becomes X1 minus X2. Then I can put plus an I. Y1 is positive, and then we have a negative Y2. And then a question, before we go to the example and then go to division and multiplication, is what is the real part of Z1 minus Z2? Someone in the meeting. Easy stuff. Go ahead.
X1 minus X2.
X1 minus X2 is that, right? Let's quickly look at the imaginary part of Z1 minus Z2. What is it going to be?
Y1 minus Y2.
Y1 minus Y2. Thank you. Right. So addition and subtraction are very easy. Let's quickly do one example. This should be example 7. You give me that, and then we go to multiplication before division. Once we can do those ones, I'm going to be happy. So that should be example 7. So if they are saying we should find W minus Z, and we are given that Z is 3 plus pi I, and W is 13 minus 25 I. So what is Z minus W? But is W minus Z, right? So how do we go about this? Someone in the meeting, please help.
We subtract the imaginary part of the real part of W with the real part of Z, and vice as well as the imaginary part after doing with the real part.
On point. So let's quickly put in our W. So it is 13 minus 25I minus Z, which is 3 plus pi I. So I'll just distribute that so that I have 13 minus 25I minus 3 minus pi I. So now when things are like this, I'm comfortable. There's the real part. There's another real part. So I can subtract those or add them. And then here's the imaginary part. And here's another imaginary part. So now life is easy. You look carefully, 13 minus 3, that will give me 10. And then I'll put the I outside. I have negative 25. And then I have negative pi. So my answer here can simply be written as 10 minus I. Then I can have 25 plus pi. So I cannot give them the decimal form of that because I do not have a calculator. And I do not know what pi is. Well, we know it's 3.14, but yes, we would leave it this way, and the lecturer would be happy. Okay, easy. Subtraction, addition, and finding the complex conjugate. Very easy operations. Let's do multiplication. Then we'll do division, and then you will see how all of these combine, and they help you to answer your tutorial questions. So let us look at multiplication, or let's say the product of complex numbers. Okay. What I want to remind you, which you should know as much as you know your name, is that the square root of negative 1 is I. Okay. What does this mean? It means that when I do I squared, which is just I multiplied by I, it is the same as doing negative 1, that square root squared, which gives me negative 1. So if you look carefully, I squared or I multiplied by I should simply give you negative 1. Very important that you know this because at times people forget and they start messing around with this easy stuff. You know, forgetting is natural, believe me. And then what I need you to also know is that I multiplied by negative I actually gives you positive 1. You know, if we have these here, we will not have problems. Okay, so I squared, which is I times I, we get negative 1. And then negative I times positive I, we get positive 1. Okay, let's quickly jump into the product. So let's say we're given Z is x1 plus I y1, and then we're given Z2, which is x2 plus I y2. When we are doing Z1 times Z2, all what we are doing is we are just dealing with void. X1 plus I y1, x2 plus I y2. This here, if you give to your sibling who's doing grade 8, they will be able to do it for you because guess what? It is just straightforward void. So we'll take that, multiply it with that, take that, multiply it with that term, and then take this one, multiply it with that, and take that, multiply it with that. Easy void. Okay, so let's go ahead and see what we have. So our Z1, Z2 will be, if we start with this one, which I'm indicating here, no, not that one, let's start with this one, where I'm putting in the black arrows. If we do that, you will see that we have x1 times x2, which will just be x1, x2. Nothing hard. And then let's go again and do another one. So let's follow the red arrow. I have x1 times I, y2. So there we'll just have plus I, x1, y2. Okay. I hope that makes sense. And let's go to, in fact, let me see if I can make something here. Let me do this. It will help me and also help you. So let's put in some green here. Push it to that so that I'm able to highlight that way so that you see what is going on. Okay, so let's go to, we're done with those, the top ones. So let's go to the bottom ones. Let me use another color here. Let's use blue. Go there. Okay, so let's do the green part. That green, this one here. So if you look at the multiplication, we have I, y1 multiplying x2. So I'll have I, x2, y1. Hope that makes sense. That would be that kind of green, this one. Okay, then let's go to the blue one. If you look at the blue one, we have I times I. So look at the blue, good people. We'll have I times I. And what is I times I? We said it is -1. Okay, so I'll have a negative there. And then we'll have y1 times y2 is y1, y2. Hope that makes sense. Please ask if you do not get what happened there. Okay, let me rather write it here so that in case you get confused. So we have plus I by 1, put it in bracket, and then you are multiplying I by 2. And if you remember, I times I gives you -1. Okay, so that's why when we come below here, I'll copy all of that and paste it here. And then just remove there. The I and the I will give us -1, so that I have negative y1, y2. Okay, This would be multiplication. So all what you do is we just do FOIL. There's nothing new. Okay, let's quickly do one example and see if we can be able to compute that. Let's go ahead and do an example this time. Example 8, and they're saying find the product of Z and W. What is Z? Z is simply 3 plus 2i. W is 5 plus 4i. So we need to find Z times W, which means we have 3 plus 2i, 5 plus 4i. Okay, let's quickly do some foiling. So let's go with this one times this one first. So if we deal with the blue, you'll have 3 times 5 plus, let's deal with the next one. It is 3. It's going to multiply there. So that will be plus. We have 3 multiplying 4i. Okay, that would be the green. And we have a pink here. Pull this down in that direction. And if you look carefully, we'll put a plus. We have 2i multiplying a 5. When you look at the pink, and let's take the last one, our orange, multiplying that. If you look carefully, we have plus, we have 2i multiplying 4i. So let's quickly try and simplify this. 3 times 5 is 15. 4 times 3 times 4i, it will give us 12i. Plus 2i times 10, that will make 10i. Then what we need to remember, we have an I times an I there. And I times I, we said it is -1. We said I, remember I times I, it gives you a -1. So I'll just put in the negative here at the front, then 2 times 4, that gives me 8. Now I can deal with the real parts. They should be adding, and the imaginary parts should be adding also. So which means my Z times W will be 15 minus 8. That will give me what? 7, I hope. And 12 plus 10, that will give me 22i. Okay, it was easy doing this thing. Do we have anyone who has a question here on finding the product? It is as easy as FOIL. So all what we do is we are foiling. But now this is where all these concepts come together. Let's do the quotient, which is when we are dividing complex numbers. So a question here, let's do division, and then I'll pick out a few questions from your study guide, and you'll see that you'll be able to answer nearly all those questions. So let's look at division. Division of complex numbers. Okay, so let's quickly look at that. So let's say we have Z1 divided by Z2, which would be X1 plus I Y1 divided by X2 plus I Y2. We have a serious problem here. We have a serious problem, which is that. And the problem is we dislike complex denominators. So we really dislike complex denominators, and There we go, we find ourselves having a complex denominator. So since we dislike it, what do? We make it disappear. And if yes, the answer is how. So to remove a complex denominator, all what we need to do is to multiply the numerator. Let me make a note for you. Take this note in the future, I will need it even next year. So the note, which is to remove a complex denominator, what you should do is multiply. What are we multiplying? We will multiply the denominator. We'll multiply the denominator and the numerator. Need you to read this carefully. By and I think you're opening drawers. Please run to your computer and mute yourself unless you want to ask a question. Okay, very important. Check if it is not you. That's
I'm so busy.
Please tell your please mute yourself. Tell your guy to come back later. Okay, let's proceed. So I was saying to remove a complex denominator, we should multiply the denominator and the numerator by the complex conjugate of the denominator. Okay, I hope this makes sense. So the first thing is we do not like complex denominators. And what do? To remove them, we multiply the denominator and the numerator with the complex conjugate of the denominator. Here's what this means. Okay. What this means is if we have Z1 divided by Z2, which is X1 plus IY, divided by X2 plus IY2. This is the problem here. And how do we deal with it? If you read my statement, I am saying to you, we will multiply by the complex conjugate of the denominator on the numerator and the denominator, meaning we'll multiply by x2 minus iy2, that's the complex conjugate, and divide by x2 minus iy2. You all understand? This would be the complex conjugate of the denominator. That's what you should always do at all times. When you're dividing complex numbers, for you to get rid of a complex denominator, you multiply the numerator and the denominator with the complex conjugate of the denominator. You should make it a song. Okay, let's quickly see what multiplying complex conjugates is. So we have complex conjugate. We have x2 plus I y2 multiplied by x2 minus I y2. Let's quickly do some foiling here. Okay, so we'll do that and do that and do this and do that. So let's quickly multiply this. So here we are multiplying complex conjugates. And I want you to look at what will happen here. So here we are multiplying, not multiplying, multi. We are multiplying complex conjugates. So look at what happens when we multiply complex conjugates, and we'll make a rule. Okay, so we have x2 times x2, which gives us x2 squared. You can agree on that. And then we'll have x2 multiplying that, which will be negative it has a negative I, so it will be negative I x2 y2. And then we take that I y2 in the green and multiply x2, we find ourselves with I x2 y2. And then we follow the orange arrow and we will have plus, we'll have our I y2 multiplied by negative I y2. So if you look carefully, this here will cancel. Okay. And then if someone can remind me, what did we say is I times negative I? It is positive 1. So that means this last part here will simply be plus y2 squared. And if you look at this here, it is the same as taking the modulus of the complex number squared. So we'll come quickly and define what the modulus is. Modulus of the complex number. So what I need you to take away is that in a complex number, I'll come back quickly. We have z. If we have z is x plus iy, we have what we call the modulus. And the modulus is simply represented by these straight two lines, and the z will be inside. The modulus is always given by the real part squared plus the imaginary part squared. So which means when we look above, it will be x squared plus y squared. And then if you look carefully, the modulus squared, when you square both sides, it will simply be x squared plus y squared. And then what you should have seen is that when we multiply complex conjugates, let's multiply z with z dash. That would be x plus iy. The conjugate, remember, we changed the sign of the imaginary part. That will be x minus iy. The answer you will get here is simply x squared plus y squared after doing the FOIL. And when you look carefully, x squared plus y squared is equal to that, and that is equal to the modulus squared. So which means, therefore, our z multiplied by its conjugate, it gives us the modulus of the complex number squared. Okay, and the modulus, we just said the modulus squared, it is just the real part squared plus the imaginary part squared. So if you look at what happens in the problem I gave you before, this one, when we are trying to remove the complex denominator, look at what happens. I need you to look at this carefully. We now have a complex number, it is multiplying by its conjugate, and we said when you have such, the answer simply becomes, let's look at the numerator. We have x1 plus iy1. On the numerator, we have x2 minus iy2. Then the denominator, we are multiplying complex conjugates. And we said when we are multiplying complex conjugate, the answer is simply the real part squared plus the imaginary part squared. So it means I just have x2 squared plus y2 squared. And this here is now real. We no longer have a complex denominator, which we said we dislike. So now this is real. And now we are happy because we'll only have complex numbers on the numerator, which we need to multiply. Here, you are able to do the product already. So do the product, which we have done before. Do we have anyone who has a question before we try to look at a question which is on your study book? Because once we do division, we have done most of the work. Now we're left with the other different forms. Someone in the meeting, please ask if you are confused. Are we following?
Yes, so
Okay, let's quickly go to tutorial questions as a refresher, and we quickly see what is going on. So tutorial questions, the very first ones. Last week, did you go to a tutorial?
No.
Active. So let's quickly look at your tutorial questions. Okay, and let's see what we know so far. So tutorial questions. So if you're on your study guide, let's go to the very first tutorial questions, which are number 1. Okay, and there they are saying expressed in real imaginary form. Right. Express in real imaginary form. So let's quickly look at A, which should be very easy. So if you look at A, they are saying to us we have P. So when they say express in real imaginary form, it means after having our complex number, you should have it easy to be able to see the real part and to be able to see the imaginary part of the whole complex number. Not spot out the real part of the denominator, the imaginary part of the numerator, and so on. So let's look at what we are given there. So for A, they gave us P plus IQ divided by P minus IQ. And we need to write this in real imaginary form, meaning at the end of the day, this should be in the form of X plus I, Y. So where we can clearly see what the X is and what the Y is. Okay, and then a question from me to you is, what is the problem here? What is the problem here? This
We have a
person
complex denominator.
on point. And remember, we said we dislike complex denominators. We said that before. We dislike complex denominators. And what did we say we should do? We said if you see a complex denominator, multiply its numerator. Put it up here. We said when you want to deal with that complex denominator, multiply the numerator by the conjugate of the denominator, which would be P plus IQ, then divided by, remember we said you multiply the numerator with the complex conjugate of the denominator and also multiply the denominator with its complex conjugate so that essentially you do not change the expression, you have a 1 effect. But our 1 is smart because it will help us to make our life easy. Okay, equals to. So on the numerator, what we have is simply P plus IQ, P plus IQ. And on the denominator, please remember that we said when we multiply complex conjugates, as you can see, there's a different sign here, it's conjugate. We said it is the same as taking the real part, which is P. If you look here, the real part, which is P, is the same as taking that, squaring it, plus take the imaginary part, which would be negative Q, and square it. So if you look carefully, our answer is simply P plus IQ, and then P plus IQ, then divided by P squared plus Q squared. Now we can deal with the numerator because guess what? Our denominator is now real. We no longer have any problems. We're not seeing any eyes there. Okay. Now we can quickly deal with that numerator by simply doing our FOIL. So let's quickly sort that out. That will multiply that. And with time, you will learn to do these things without even thinking. And it takes practice. So let's quickly fix the denominator. the numerator, sorry. So P times P will be P squared. And then IQ, or P times IQ, it will be I PQ. And then we go with the pink one, IQ times P, it will be I PQ still. And then we have IQ times IQ. We remember that I times I is negative, so I'm going to put the negative. Q times Q squared, so Q squared, divided by P squared plus Q squared. Remember, they said real imaginary form, meaning it should be clear what is real and clear what is imaginary. So let's gather the numerator. So these are the real parts, green ones, and the yellow ones are the imaginary parts. So let's go ahead and see. So our real part is P squared minus Q squared on the numerator, and then I times PQ plus PQ, it is 2PQ. And then divided by our denominator, which is P squared plus Q squared. And obviously, as you know, we can make a common denominator here by simply having P squared. Let me shrink this so that we have some space. Okay, let's create some space. There we go. So we can make a common denominator and have P squared minus Q squared divided by P squared plus Q squared. Now it is very clear what is real. I times 2PQ divided by common denominator P squared plus Q squared. So we can now see that this is real. And the other part, which is multiplied by I, is imaginary. So your lecturer for the first question of your tutorials was expecting you to be able to see that we actually dislike complex denominators. And then you would multiply by the conjugate of the denominator on the numerator and the denominator. And then you sort that out. Do we have anyone who has a question? Anyone who has a question here? Okay. No question. Let's quickly jump into another question. Let me see. Let's take D. Let me take D. The rest will just be easy, but a lot of work. Let me take D because we can do it quickly. So for D, we are still expressing in real imaginary form. Remember that. Okay, so for D, what we have is 17 multiplied by 1 plus 2i divided by 1 plus 3i, and then multiplied by 1 plus 4i. Okay, so here we have another problem before we need to deal with the real problem. Someone in the meeting, please tell me, what problem do we need to sort before dealing with the problem which will come out of the problem we are trying to sort? Tell me if I'm speaking a foreign language. What do we do here?
So I think first we need to deal with the product on our denominator.
On point. So we need to deal with this one first so that it becomes one complex number. Okay, very smart. So let's quickly deal with that. So you'll have 1 times 1, and you will have 1 times 4i, and then you'll have 3i times 1. And the last one, you'll have 3i times 4i. So let's quickly deal with that denominator. You'll have 1 times 1 plus you will have 1 times 4i. And then plus, when you look at the green one, we have 3i times 1, plus when you look at the pink one, we have 3i times 4i. Okay, so if you look at that, which is the denominator, 1 times 1 is 1, plus 4i, plus 3i. Remember we said I times I is -1, so we'll have a negative 3 times 4 is 12. So when we sort that out, you can clearly see this is real, and the others are just imaginary. So our answer will be 1 minus 12, that will be -11, and 3 plus 4, that would be 7i. Okay, so we dealt with the first problem, so now let's go back and rewrite our problem. So we have 17 into 1 plus 2i. Remember, this is the denominator. We had to FOIL it because we have two complex numbers which are multiplying. We want to make it 1 first. Then divided by -11 plus 7i. Okay, now this is what we have. The question to you all in the meeting is, are we faced with a problem here?
Yes.
Yeah. Okay, you're saying yes, and then what should we do? We are engineers, we need to solve problems.
Multiply by the conjugate of the denominator.
On point. So we should multiply by the conjugate of the denominator. What is that? What is the conjugate of the denominator?
-11 minus 7i.
Okay, on point. And what you do on the numerator, you do on the denominator. Okay, so let's take that and put in the 17 outside. 1 plus 2i, -11 minus 7i. Let's quickly deal with the denominator. So remember, you should make a note. We said when you're multiplying a complex number by its conjugate, the answer becomes the real part of the complex number squared. So it becomes, it becomes the real part squared, which as you can see there, it is -11 plus, and then the imaginary part squared, which is 7. Okay, that is very important. So make sure that you remember that when you are multiplying a complex number by its conjugate, it simply becomes the real part squared plus the imaginary part squared. So now we need to deal with the top part. Let's quickly deal with it below. So I'll keep the 17 outside here and quickly do the foiling. So we'll have that and that. And also what you should practice is speed. Obviously, I cannot move as if I'm the one who's writing here. Okay, so let's quickly do the foiling at the top. So 1 times -11 is -11. 1 times -7i, when you look at the green, it becomes -7i. 2 times 2i times -11 becomes -22i. Then 2i times -7i. We said I times -i gives us a positive. Then we have 2 times 7, which gives us 14. Divided by, people who are good in calculations, what is 11 squared? Remember,
121.
121. What is 7 squared?
49.
49. You guys are very smart. 17 into. So let's quickly group the real parts. Real people belong together. And then let's do the imaginary parts. So -11 plus 14, that should give me a 3. And then the imaginary part, we have -7 and -22. Sounds like it is going to give me -29i. Divided by 121 plus 49, what is that? If this was money, you would have put in the answer already. 129, 121 rands plus 49 rands. What is it? I think it should be 170, I hope. Okay. And then if you look carefully, 17 and 170, they cancel, leaving us with 3 minus 29i divided by 10. Okay. And finally, this is when your lecturer starts smiling and they're like, you know what? This person listens in class. So finally, we have a common denominator, so which means we can have our 3 over 10 minus 29 over 10i. And now the lecturer is saying, look, you are able to give me the real part, and you are also able to give me the imaginary part. So you deserve to pass because this thing is easy, and you are able to do the easy things right, which means you can learn and do the hard things. I need someone who's confused. Who did I lose and where did I lose you? If you are in the meeting and you are sitting there, you are like, I do not understand what is going on. Where did I lose you? Okay, there is silence. I'm going to do F with you, and then we go down a bit and comment on a few things, and then I'll open the room for more questions. Please stop me if you do not understand as I go. So let's go to F. And let's see what we're expected to do. Still on F, we need to write this in real imaginary form. And all of you in the meeting are supposed to be able to get this right. 2 divided by 1 plus cos theta plus I sine theta. Okay. Then a question to the people in the meeting is, how do we go about this? We can see our denominator is complex, and as we said before, we dislike complex denominators. So what do we do here? Your brain should be firing with ideas, okay? What do we do? How do we deal with this? Do we out of nowhere say maybe theta is 30, you know, this will make life to be easy? What do we do?
I think we do the same thing, like we multiply by the conjugate of the denominator.
Okay, very easy, on point. Whether there's thetas or what, we do not know theta. We know that if you give us theta and we put in there, it just becomes a number. So it really does not matter. We need to do what we need to do. We need to eliminate this complex denominator. How we do that? We multiply the numerator by the conjugate. So what is the conjugate of the denominator? People in the meeting, conjugate of the denominator, what do we have?
Minus I sine theta.
Minus I sine theta, on point. And then we also divide by the conjugate of the denominator. We are still not convinced that this thing is, I am worried. Okay, so let's quickly go and deal with the denominator. So 2 times 1 plus cos theta minus I sine theta. We go to the denominator and we start making some noise, okay? We remember that if you are multiplying a complex number by its conjugate, all you do is to simply take the real part it, take the imaginary part and square it. So let's go ahead and take the real part. So the real part is that, which means to come here and say 1 plus cos theta squared plus the imaginary part we need to take and square it, sin theta squared. Hey, someone is there, Mike. Unless you are asking a question, mute yourself. So let's look at the numerator. If I quickly FOIL, I will have a 2 plus 2 cos theta minus 2i sin theta. Someone has their mic on and it appears they are not even on their laptop. I don't know if they are cleaning. Hey, please your laptop. Let's quickly square that bracket. So if you square it, you will get 1 plus 2 cos theta plus cos squared theta. And then when you square sine, you get that. And then if you remember from grade 11, what is that?
One.
1 point, sine theta. So it is going to be 1, and then we'll have a 1. So 1 plus 1 will be 2. So I'll factor out that 2 from the denominator such that I will have 1 plus cos theta. Hope that makes sense. And we have terms which are going to cancel. Okay. And then our final answer will be 1 plus cos theta minus I sine theta divided by 1 plus cos theta. And then the lecturer wants you to show them what is real and what is imaginary. And then you say we have a common denominator, so cos theta divided by 1 plus cos theta, and then minus I sine theta divided by 1 plus cos theta. And as you can see, this will end up giving you the 1. And when you tell the lecturer, quickly show them that this is my real part. I think I know what I'm doing, and this is my imaginary part. I think I know what I'm doing. Okay. Anyone who got lost anywhere, please speak up. The intention is to save you time. So instead of sitting by yourself for 15 minutes figuring something which we could have easily shown it to you in 3 minutes, I think it is not a good use of time. Okay. Let us quickly go to let me quickly pause here. In class, did you get to the complex plane and then eventually the modulus argument form? How is your pace? Those were 2 classes this week. Where did you stop?
Oh yes, we did the argument forms there.
On point. You are moving at a rate. Okay, so let me quickly go down and quickly show you some sketching. What happens up here? Really, let me solve that. Okay, we'll deal with that later. So let me do this with you. Let me come here and wait. Where is my Teams? Okay, so let's do this with people. Let me give you a quick break because I want you to get up to speed with play. And then I'll draw a diagram for you, which will be useful, in fact, forever, for the real imaginary form. So let's take a break from now, which is 11:48. Let us come back in, let me see, 48, 58. Okay, so let's take a 10-minute break. Please stand up and then get a glass of water and look outside your window and reflect. We'll start in 10 minutes. Let me pause this and we will commence again. This does not mean you should leave the meeting. Keep